Today we will be discussing problem related to collision. This problem was asked in IIT 2008 examination. Now in this problem, a block of mass m slides from A to B and then from B to C. So A to B is an incline of 60 degrees with horizontal and B to C is another incline of 30 degrees with horizontal. We want to find what is the speed of block at point B and what is speed of block at point C if collision is inelastic collision. In the third part, we will be finding that if collision is elastic collision, then what will be velocity of block at point B? These are things we are supposed to determine. Now, first we'll start with the first part. So we want to find speed of the block at point B immediately after strike the second inclined plane. For that, we'll assume that let this height we'll assume as h1. This height we'll assume as h1. Now in this triangle, from figure, tan 60 degrees is equals to opposite side by adjacent side. Opposite side by adjacent side. So that's equals to, so in the triangle, opposite side we can, opposite angle 60 degrees is h1 and adjacent side is nothing but this side. So this will be equals to root 3. So that's why root 3. So we know that tan 60 degrees is equals to root 3. So we'll get root 3 is equals to h1 by root 3. Or we get cross multiplication, h1 is equals to 3 meter. Root 3 into root 3 will get 3 meter. Okay. So after finding this one, we'll find velocity at point B. So velocity at point B, we can write it as Vb is equals to under root 2g h1. Vb is equals to under root 2g h1. So that's equals to under root 2, g is given as 10, h1 we got it as 3. Therefore, it's equals to root 2 into 10, 20, 20 into 3, 60. So root 60 meter per second. So we got the first part. So when the velocity, when the body reaches point B, the velocity of body will be equals to root 60 meter per second. Now in the second part, we want to find what is the velocity at point C. Now when body slides from A to B, the direction of velocity will be along AB. So A will extend it like this. So this is the direction velocity VB. We'll assume that this height is equals to h2. We'll extend this horizontal line. So next action the horizontal line. Now you can observe that these two this line is same thing. So these two lines are intersecting. This line as well as this line are intersecting. So this angle is 60 degrees means this angle will be also 60 degrees. Okay. Now these two are parallel. So these two are parallel means if this angle is 30 degrees means this angle will be also 30 degrees. Therefore, this angle will be So 60 minus 30, that will be 30 degrees. Okay. So velocity in this direction is VB. Now you want to find velocity in the direction BC. So this velocity we want to find. Now for VB, this side is adjacent side. So I can write this velocity will be VB cos 30 degrees. VB cos 30 degrees. So let me call this as, so I am writing here. So velocity VB cos 30, let me call it as VB dash, is equals to VB cos 30 degrees. So VB, we got it as root 60 into cos 30 degrees is nothing but root 3 by 2. So this I can write it as root of 60 into 30 divided by 2. So that's equals to root, sorry, this one is 60 into 3 is equals to 180 divided by 2. So 180 divided by 2 means we'll getting this as 45, root 45 meter per second. Okay. Now we want to find velocity at C. We got velocity at B. We want to find velocity at C. For that, we'll apply law of conservation of energy. So by law of conservation of energy, we'll apply at point B and at point C. So I can write total energy at point B is equals to total energy at point C. Total energy is nothing but sum of potential energy plus kinetic energy. So I can write potential energy means mgh2 plus kinetic energy means half m velocity vb dash square is equals to. So at C is on ground, so potential energy is 0 plus kinetic energy is half m v c square. So I'll assume that velocity at C is Vc, so Vc square. You can cancel m throughout. Multiply with 2 throughout, so we'll get 2gh2 plus vb dash square is equals to Vc square. Okay, so we are supposed to find H2. So for that, so I'll write it here. So from this triangle, so tan 30 degrees is equals to opposite side by adjacent side. So I can write from figure tan 30 degrees is equals to opposite side is H2 by adjacent side is 3 root 3. So tan 30 degrees is equals to 1 by root 3. So that's equals to H2 by 3 root 3. So root 3 cancels. So this implies H2 is equals to 3 meter. So now I'll substitute this value of H2 in this equation. So this will become 2g, g means 10. So in place of g, I'll write it 10 into H2 is 3 plus velocity VB dash is nothing but root 45. So root 45 whole square is equals to VC square. So root and square cancels off. So 30 into 2, 60. 60 plus 45, 105. So this implies we'll get VC square is equals to VC square is equals to 105. Or I can write VC is equals to root 105 meter per second. Okay, so after determining VC, now we'll go to the last part. If collision between block and incline is elastic, so in the problem it is given that elastic collision, then we are supposed to find vertical component of velocity at block B immediately after it strikes the second incline. Okay, now A to B, body is moving like this, so its direction of velocity V at B will be in this direction, which we call it as VB. So let me extend it horizontal line. Okay. Now this angle is 60, means again this angle will be 60 degrees. This is 30, means this is also 30 degrees. So this is angle also 30 degrees. 60 minus 30, that's also 30 degrees. Okay. Now, since collision is elastic collision, we can write velocity, angle made by velocity, angle made by velocity of block before collision must be equals to angle made by velocity of block after collision. So you know that angle made by the block, velocity of block before collision is 30 degrees. So after collision again is 30 degrees. That is, final velocity will be in this direction. So that is we are getting. So this implies velocity of block will be horizontal. Okay, velocity of block will be horizontal. He is asking vertical component of velocity. of the block. So vertical direction, vertical to BC, there is no velocity. Therefore, velocity of block along vertical to BC will be 0. Therefore, velocity of block along vertical to BC is 0. This is the final conclusion we can draw it. Okay, so let us revise the problem once again. So we had observed that block is traveling, block is at a height h1 from point B. So from figure I can write tan 60 degrees is equals to opposite side by adjacent side. This side will be equals to root 3. So you'll get h1 by root 3. So h1 you can find out. Now we want to find velocity at this point B. So we will apply inclined plane concept. So I can write velocity at B is equals to VB is equals to under root 2g h1 under root 2g h1. So to gh1 substitute the values, we'll get root 60. This is the first part. Now second part, we want to find velocity at C. For that, we'll draw this height as h2. The direction of velocity will be along AB. So VB will be the direction of velocity. So first we'll determine the h2. So from figure, tan 30 degrees is equals to opposite side, that is h2, by adjacent side is nothing but 3 root 3. So we can find h2 is equals to 3 meter. Then velocity of the block will be along the direction AB. So we want to find velocity in this direction BC. So this angle, you can observe the diagram. This is horizontal line. So these two angle between these two is 60 degrees. So angle between these two will be also 60 degrees. Now these two lines are parallel. So this angle is 30 means this will also 30 degrees. So naturally this angle will be 60 minus 30, that's equals to 30 degrees. So velocity in this direction will be equals to VB cos 30 degrees. So this velocity, let me call it as VB dash. So VB dash is equals to VB cos 30 degrees. So we had determined VB in first case. So cos 30 is root 3 by 2. Substitute it and simplify, you'll get root 45 meter per second. Now apply law of conservation of energy between point B and C. So total energy at B is equals to total energy at C. Total energy is nothing but sum of potential energy plus kinetic energy. So potential energy plus kinetic energy at B must be equals to potential energy plus kinetic energy at C. C is point on the ground, so potential energy I had taken as 0. Now multiply throughout by 2, we'll get this equation. Simplify, we'll get the value of VC. After finding VC, we'll go to the third part. Third part, it is mentioned that the collision is elastic collision. Collision is elastic collision. We want to find vertical component of velocity of the body. Now, for elastic collision, angle made by velocity of block before collision is equals to angle made by velocity of block after collision. So the block is moving in this direction, AB, along the direction AB. So this is the direction of velocity VB. Before collision, this is the direction. Now, this line I am extending forward. You can observe that these two angle between these two is 60. So angle between these two will be also 60 degrees. Also, you can observe that these two are parallel. So this angle is 30 degrees. Means this is also 30 degrees. So this angle will be 60 minus 30. That is 30 degrees. So we know that angle made by velocity of block before collision equals to angle made by velocity of block after collision. So this is 30. This is also 30. So resultant velocity will be in this direction. So velocity of block will be along horizontal direction. So in vertical direction to BC, so along this direction, vertical direction to BC, there is no velocity. So velocity of block along vertical direction is 0. So this is how we are able to solve this problem. Hope you are able to understand clearly. Thank you.